So as you've been hopefully learning about, watching the videos that are called Shedding Light on Atoms, we're going to talk about the development of atomic theory. We're looking at some of the history behind what we currently know about atoms. So how can something so large as a dinosaur and so small as an atom have anything in common? Well, really, they have a lot in common as far as things like the fact that we haven't seen either one of them. We can't see an atom, we can't see a dinosaur directly, but we know of their existence because of indirect evidence. We know of dinosaurs because of fossils left behind. We can predict what they may have looked like based on what we understand animals currently to have for structures. Atoms we've never seen, but based on evidence from many different tests for hundreds of years, we can see that they exist. And like our theory of dinosaurs, our theory of atoms have changed over time as well. So where did it all start? Well, it started back with the ancient Greeks and a man named Democritus. Democritus was a philosopher. He lived from about 460 to 370 BC. And as you may know, philosophers are thinkers. So he spent a lot of time thinking about the world around him. He looked at what was going on around him, and at the time lived with people who believed that everything that was present in our world was based on four essential components. Either it was fire, it was water, it was air, or it was earth. He looked at that and went, now that's kind of strange. Those are good categories, but I can't see how you could put those things together and make different things. And he started thinking about it, and ultimately, one of the things that he thought about was plants and trees. And he said, you know, these plants and these trees, they grow out of the ground, they grow up, they live, they die, and they go back to the ground. When they go back to the ground, it's like they give themselves back to the ground to be used again to make and build a new tree or a new plant. And so he saw that as little things that just kept getting rearranged. He also thought about the idea of dividing matter. And he said, if we cut it in half, and then we cut it in half again, and we cut it in half again, and we cut it in half again, although everybody else in the day would say you could do that forever, Democritus said that doesn't really make sense. We couldn't cut something in half forever. At some point, we have to come to an indivisible piece, a piece that we can't cut in half. Because if we could cut things in half forever, it would be like saying that in a race, you could cut the distance between yourself and the finish line in half and then cut that distance in half and so on. But if you could cut it in half forever, nobody would ever finish the race. And we know that that's not true. So he said there has to be a limit to this idea of being able to cut things in half. And ultimately, he said, that means there has to be a tiny little indivisible particle that we stop at. And he called that atomos, for the Greek word indivisible, or not being able to be divided. Unfortunately, Democritus is one of the lesser known Greek philosophers, and he lived in the day of Aristotle. And I would guess most of you had heard of Aristotle, and probably none of you before now had heard of Democritus. Aristotle was one of the philosophers who believed you could divide matter into smaller pieces forever. And because he was the better known philosopher, he was more highly regarded. He had a very strong influence over popular belief, and his views then were accepted. Crazy enough, because Aristotle was more popular, he held science down for about 2,000 years. So what is an atom? Well, we kind of already have gone over this, but let's make sure that we have it clear in our brains, right? An atom is defined as the smallest particle of an element that has the properties of the element. So if we have a piece of carbon, the smallest piece that is still carbon is a single atom of carbon. If we divided it any further, we wouldn't have carbon anymore. In order to be carbon, it has to have the right combination of parts. So how do we eventually get to the understanding then that Democritus was sort of right? Well, it takes about 2,000 years. And a lot of people in between time working on different things, not necessarily that idea. There were, because of the idea that everything was made up of the 4 basic elements, people who thought that you could then make gold. They were called alchemists. So they were doing lots and lots of experiments, hoping to be able to strike it rich by making gold. Obviously failing at that attempt, but they became the first scientists, really. They developed a lot of tools, and they set up a lot of workshops and became really, really good at doing scientific discovery. I mean, they had a wrong approach or a wrong idea that got them working, but they still discovered a lot of things. Prior to John Dalton, they discovered things like the idea of the law of conservation of mass. They discovered ideas that things rearrange and recombine to make new things, and so on. And so John Dalton, working with some of these ideas, he performed a lot of experiments on how elements join together to make new substances, and you saw a lot of that in the videos. John Dalton then began to realize that Democritus's idea of a single atom being the smallest part of one of these elements was probably on the right track. And so he goes back to the Greek philosopher and he takes his idea and builds on it with the things that they have since discovered, and he puts together an atomic theory. There are 3 main ideas in Dalton's atomic theory. There's more than 3, but the 3 main ideas are this. He proposes that all substances are made of atoms, which are small particles that cannot be created, divided, or destroyed. So really a restatement of what Democritus was saying. So how is it that John Dalton can propose this and it can be a theory? Democritus proposed the same idea and it only be an idea. Well, because Democritus was only a philosopher, Democritus only had thoughts. He didn't have any kind of experimental evidence to back up what he was saying. John Dalton, building on the work of others and his own work, had experimental data to support what he was saying. So John Dalton could develop a theory. Democritus could only give us his ideas. The next statement in Dalton's atomic theory is that atoms of the same element are exactly alike and atoms of different elements are different. So what he's saying here is that every single atom of carbon would be identical. Every single atom of silver would be identical. But silver atoms would be different than carbon atoms. And then he also says, as his third main point, that atoms join with other atoms to form different substances. So essentially what he's saying is that these atoms rearrange. They're not created or destroyed. They're just regrouped or rearranged to make new things. So That's where our modern atomic theory begins to build from. This idea of a tiny little indivisible particle. You could really almost think of it like a ping pong ball or a tennis ball, just a solid ball. I know ping pong balls and tennis balls are empty, but you get what I mean, right? This just tiny little ball that everything is made up of. That's where we start. After John Dalton comes J.J. Thomson. J.J. Thomson is working in the age of electricity, really. And people at the time are using this cool little device. You see it down here at the bottom of the page, called a cathode ray tube. And a cathode ray tube is essentially a glass tube with gas in it. It has a cathode on one end and an anode on the other end, and electrical hookups to both ends. And when the electrical switch is flipped on, a beam of light shines through this tube. He messes with this cathode ray tube, and ultimately he begins to realize and discover that that tiny little stream of light is actually a stream of tiny little particles that are even smaller than atoms, and those tiny little particles have a negative charge. Well, how did he figure this out? Well, if you look at this as basically a cathode ray tube with the blue line representing the cathode ray, the stream of light that's passing through it, what J.J. Thomson did was he introduced a magnetic field near that cathode ray. And what he found was that when the positive side of the magnetic field was near the cathode ray tube, that the ray was attracted to the positive field. So you can see that in this picture here, this diagram, right? You have this positive field above and the ray bends up toward it. Well, as we know, opposites tend to attract. J.J. Thomson knew that as well. So if we have a positive attracting something, the cathode ray, that it is attracting must be a negative. He did further work, and so did a guy who came about the same time as him, named Millikan. And what he found out using a mass to charge ratio that you don't have to understand yet, you can learn more about that in chemistry, is that these tiny little negatively charged particles have a mass much smaller than the mass of even a hydrogen atom, which would be the smallest atom. So in his experiment, what he proves is that these tiny little particles are smaller than atoms and they're negatively charged. So he proves John Dalton wrong because now he has proven there is something smaller than an atom. He calls those things the electron. And so he develops a new theory. He develops a model of the atom called the Plum pudding model. All that he knew is that things are made up of atoms, from John Dalton, and that there are tiny little particles inside of these atoms that are negatively charged. So what he believed to be true was that the atom must be essentially a mass of positive that has negatively charged little tiny electrons in it, much, much smaller than the atom itself. His model, he calls the plum pudding model, because in England, where he's from, they would eat plum puddings at Christmas time. I would say this looks a lot more like the chocolate chip cookies in chocolate chip cookie dough. So if we can imagine a ball of chocolate chip cookie dough being the positive part of the atom, the body of the atom, and the chocolate chips inside of the dough, the negative electrons, then we kind of have an understanding of J.J. Thomson's plum pudding model.